this video, we're going to have a look at gradient of a line. Imagine you're out hiking and you're walking up hill 1. You would say that it is less steep than hill 2. The steepness of a line is called the gradient. In the first graph, I have plotted two lines that could represent going up hill 1 and going up hill 2, and in the second, going downhill 1 and downhill 2. Lines that slope up from left to right have a positive gradient, and lines that slope down from left to right have a negative gradient. To find the gradient of each line, we measure how far up the line rises for each unit change it moves in the horizontal direction, which we call run. We say that the gradient equals the rise over the run. Let's calculate the gradient of each line. The gradient will be the same along a straight line, so we can pick any two intervals to calculate the gradient. For line 1, I'm going to draw a triangle where the run is 1, and I can then see that the rise is also 1. If I'm not sure, I could pick another interval. The run is 1 and the rise is 1. Therefore, the gradient of line 1 equals the rise, which was 1, over the run, which is 1, which is 1. Now let's do it for the line 2. Again, I can pick any interval. The run is 1, and here the rise is 2 in this case. Let's check it again in another interval. The run is 1, and the rise is 2. Therefore, the gradient of line 2 is the rise being 2 over the run being 1, which is 2. We knew that line 2 was steeper than line 1, so it has a greater gradient. Now let's go to the graph of the negative gradients. Looking at line 1, again, I can pick any interval. I go a run of 1, and this time the rise, we say, is negative because it's going down. So the rise is negative 1. Let's check another interval. The run is 1, and again, the rise is negative 1. So for line 1, the gradient equals the rise, negative 1, over the run, 1, which is negative 1. Now let's do it for line 2. You have to be careful where you choose. I couldn't start my triangle here because well, I could, but I'm on a half mark, so I want to make it easy for myself here. So I'm going to pick a point that crosses the main intervals. Run 1, and this time the rise is negative 2. Let's check again. Run 1, going down by 2, rise negative 2. So for line 2, the gradient equals the rise, negative 2, over the run, 1, which is negative 2. Here's another example, and we'll follow the steps. Step 1, we find 2 points on the line. Now be certain of these points. So I'm going to choose this point and this point. I'm going to draw a triangle, and step 2, I'm going to determine the rise and the run. The run this time is 2, and the rise is 1. Now there's another way we could have done that. We could have gone choosing another interval where the run was 1 and the rise was a half. Let's see if we get the same answer. So using our first triangle, the gradient equals the rise, which was 1, over the run, which was 2, so we have a gradient of 1/2. Using the second triangle, the gradient equals the rise, which was 1/2, over the run, which was 1. 1/2 divided by 1 is 1/2, so we get the same answer. In these three graphs, they all have a gradient of 2. Let's check. Run of 1, rise of 2. Run of 1, rise of 2. Last one, run of 1, rise of 2. Rise over run giving us 2. We say then that these three lines, all having the same gradient, are parallel lines. No matter how far parallel lines extend in either direction, they will never cross because they have the same gradient.